I asked ChatGPT to analyze this image. As you see, is a spectrum, absorption spectrum of some material, right? And it is not really clear what material. It's not really mentioned or written that what kind of material is that. So I just uploaded that picture as a PNG file and then asked that what type of a spectrum or absorption of a spectrum is that. And the answer was quite interesting. I just asked what material does this spectrum belongs to, and what I got was quite right. So this was the absorption spectrum of liquid water. And it seems that the image shows water's absorption characteristics across different regions of electromagnetic spectrum, ranging from ultraviolet to extremely high frequency EHF. The high absorption in certain infrared region is typical for water, as it absorbs strongly in the mid IR range due to molecular vibration. And the answer was 100% correct. So this was quite astonishing. Then I wanted to actually ask another chatbot, but unfortunately I do not have a plus ChatGPT, so I cannot really ask a lot of questions. So I wanted to generate something. So I wanted to ask ChatGPT if he can generate the spectrum, for example, in V's or infrared area of a specific material. For example, I don't know, like a PVC. So you are familiar with the PVC. And for that, I actually use another chatbot that called Julius. I basically asked that, can you generate an absorption spectrum of PVC from 300 to 700 nanometer wavelengths in PNG format? And what Julius actually did was quite amazing. He tried first time he tried to create a Python file, and this Python code basically resulted in a PNG format picture. So the first time he tried, he failed. The second time he had also problem, so he tried to modify the version. But the third time he apologized basically, and third time he tried, and basically he made this plots for me, which is a PVC absorption spectrum from 300 to 700 nanometer. And astonishingly, that is correct. I was surprised because I just double checked that, and as you see, this is a picture from a experiment that shows that PVC from basically 200 to 800 nanometer, how is the spectrum. And this shows that chatbots are really getting able to generate and even to detect, if you provide enough information, the spectrum of many materials. So you can basically provide some information, raw data, and they can guess what type of material is that. This is amazing because there are some basically software available on the market that you basically give the raw data, and then you can actually get the type of the material. But this is something that I didn't know that, but I'm actually learning that chatbots are basically capable of generating such or analyze such data that it's beyond I was just thinking like it was beyond the capability of such chatbots. So they really can analyze data. And that's something that makes me really happy that such tool exists and you can use for your daily tasks. Another things that I would like to talk this episode for with you is about basically hyperspectral and multispectral imaging. So basically, we have these wavelengths starting from gamma ray to the X-ray, and then comes to the ultraviolet, and then there is a very tiny branch of these, and then gets to the infrared and microwave and the radio, right? So what is the difference of hyperspectral and multispectral? Basically, they are similar. Basically, the concept is similar, but multispectral um, is used for some defined wavelengths. So, what makes the hyperspectral interesting is that it's a continuous wave from like very small nanometer, 100 nanometers, for example, to a big range of end of the near, for example, nanometer. So it comes like in a package. So it means that it is not really cut to the small pieces like multispectral. It's one piece and one big data that when you move from left to right, from the short wave to the long wave, you can get a lot of information. That's why hyperspectrals application are quite vast, especially in detection, environmental detection, using by satellites to view a broad range of materials that exist underground. So that's why that we call it hyperspectral. There's a very interesting image here. Like I think I would like to show you. Not this one. If I could save it, I don't know if I have it now. It seems that I don't have it, but it shows that how the satellites can detect basically soil, the material that exists in the soil, the material that exists in the vegetation, the material that exists in basically water. Everything is detectable via using hyperspectral. To make it more clear for you, I think this picture speaks a lot. So there are four different type of hyperspectral detectors that are available on the market. So the first one is so-called, I guess, Whisk-Broom mode. The first one, A, is like a tiny small point that is taken. So it's not an area, it's just a point. And you take, in z-axis, you take a range of wavelengths, right? But it's a very small point. Then we have an area, like a line that is called push broom mode. And then comes the third part, or the seed, which is a plane scanning. And plane scanning are in X and Y axis, like a really an area that you scan, but at a specific time, and then you get all this information in one package. And the last but not least is that the single shot mode, which comes as a square, like it means that one shot and you get all the information in one package. So that's basically as much as you more information you get, it takes more energy, processing time, collecting, achieving, data logging, and everything is bigger. So these are four different available detector unit of hyperspectral that exists in the market. Another image that could be also interesting is this one. So basically, for normal activity we use camera, right? The cameras are basically detector modules or sensors in these field or area. So we have cameras that they have 3 channel RGB, so we know that, and RGBs are somehow like a multispectral because they have some specific wavelengths that has a peak on that. So for example, blue has its own peak, green has its own peak, and far away red has its own peak. So it's like that, it's not a continuous. So every channel, every filtering has its own peak, and we detect based on that. So basically the colors are created basically with these three color, and we see it a continuous color, but in reality it's RGB cameras are just a mix of these 3 colors. And as I said, as you see in this picture, the quantum efficiency curve for an RGB camera curve showing the overlap between red, green, and blue, which is, as I said, it's in a Wiz area. This picture is also quite interesting. As you see, that's the multispectral. These are the specific wavelengths that you need, for example, based on your application. So also you do not need to get all those information in different or continuous way of wavelengths, but you need just to evaluate what specifically you need, or you want to detect a specific materials, so you use this as multispectral. But on the other side, hyperspectral is continuous, so you can get a lot of data, and you can just scroll, like go deep in the z-axis and get for example in infrared region or far infrared region, the data that, or the materials that are more visible in that part of the spectrum field. So yeah, so this is something that it makes a difference between hyperspectral and multispectral. And as I said, there are a lot of applications, especially by investigation of the land field, and a lot of application field also exists in environmental detection. So basically also in medical industry, you can get a lot of useful application for hyperspectral to detect abnormal activities or abnormal symptoms on the skin, for example. This can be detected by hyperspectral spectroscopy, and get a lot of information out of the abnormal symptoms or on the skin. For example, if someone gets skin cancer, it is much more easier to detect with the hyperspectral spectroscopy the information, because it goes deeper under the skin, and in the near area you can get a lot of information out from the skin. This is also another example. So medical, what's called satellite weather condition inspection, and this kind of things. So yeah, this was something that I wanted to talk about, and I hope that was useful for you to understand what is the difference between hyperspectral and multispectral spectroscopy. And yeah, so hope you enjoyed this episode, and see you next time.